Today is February, I've forgotten already.
26.
26, 2015. Let's do this problem. All right, so we're given a vector, and that vector is a v vector. We mean it's a velocity vector, and we're asked to find what is the position of the vector at time t. At time t equals 3. All right. Let's remind ourselves that what we have is fundamental theorem of calculus 2 again. All right. What we have is that we want to know what is the great. And the pen isn't working. Hold on. We got all this all in the recording. This is good. This is all good.
Technical difficulties.
Yeah. Please stand by. All right. Okay, here we go. This should work now. All right.
Can we just edit
So-
this out?
Oh, it's better if you get the whole thing. So we want to know what is the position at time 3. But remember, this is a vector. Okay, so actually what we're going to have is two positions, an x position and a y position.
Yeah.
All right?
Can you list it as that?
Well, what I want to do is I'll write this out in vector form, but typically we'll do this in separate pieces. What is going to be the x position at time 3? It's going to be the x position at time 0. Sorry, the x position at time 0, not the s. Helps if you erase it to write the letter x, that you write x. Okay, plus the displacement that happens during that time. And that displacement happens as an integral from 0 to 3 of what? Of the x component of the velocity vector. So that's going to be t plus 1 to the negative 1 dt. Okay? And that takes care of the position, at least the x portion of the position. What about the y portion? Well, we have some initial position, and then we have the displacement that's going on from 0 to 3, and in that case, that's of t plus 2 to the negative 2 dt. So there's going to be our new position. All right? Let's see if we can do some damage here. What is the initial condition? 3. Plus the integral. Okay, wait, can we do the antiderivative of that? The antiderivative of 1 plus t to the negative 1. I think that's natural log absolute t plus 1.
Yeah.
As evaluated from 0 to 3. That looks like we can do that.
Yes.
Do we have a y position,
Negative
initial
2.
position? Negative 2. And what about this antiderivative? The antiderivative of t plus 2 to the negative 2.
Negative t plus t to the negative 1.
I don't know. I have a hard time doing this without actually doing the u substitution and actually doing. So I'm going to declare that we're going to do a little bit of side work over here. I want the integral of t plus 2 to the negative 2 dt. I'm going to say u is equal to t plus 2. So therefore du is equal to dt, which means my rewrite is going to be u to the negative 2 du. Add 1. So u to the negative 1, reciprocal, negative u plus c, or negative t plus 2 to the negative 1. So if I did that correctly, I should be able to bring back down here negative t plus 2 to the negative 1 as evaluated from 0 to 3. Double check it. Did I get all that right?
Yeah.
Okay, so let's go ahead. Let's evaluate these antiderivatives on these intervals. And I get 3 plus the natural log of 4 minus the natural log of 1, comma. Of course, we see natural log of 1, jazz hands, because
It's 0.
that's 0, that just goes away. All right, what do we got? Oh, no, that's good. That's good. Negative 2 minus, and then we'll plug in that 3 and get 1/5 minus a minus, we plug in the 2, and we get a 1/2. Double check to make sure I did the arithmetic correctly.
So that's a half.
All right,
Looks right.
so super plus there. So it looks like our final position in the final x coordinate is just going to be 3 plus 4, next log 4, and 1/2 minus 1/5 is going to be 4/5.
You lost me.
No,
1/2 minus 1/5. 1/2 is 5/5 minus 1/5 is 4/5.
What?
50
How?
cents minus
Hey.
No.
1/2 is not 1.
It's 2/5.
yeah.
2/5.
2/10.
20 cents
1/2
minus.
5 tenths.
Oh,
It's 5 tenths minus
5 cents
2.
minus 2 tenths.
It's 3 tenths.
3 tenths.
Yeah.
Thank you.
3 tenths. 3 tenths. Okay, so 3 tenths times the negative 2.
Wait, why is
No, it's not a times.
It's plus a
it's
negative.
a minus. Or it's a plus.
Oh, that's a plus.
Yeah, totally.
Okay, so now we're at
Negative.
5
plus-
tenths.
We're at negative
3.
1.
We're at negative.
We're at negative 2
Plus
plus 3 tenths.
Yeah.
So negative 1.
So it's negative.
So it's negative 1.7.
Yeah.
Yeah.
Okay.
Negative
The answer
17
is negative
tenths.
7.
Well, guess what? That's
Okay,
it.
that's it. I'm submitting these for entertainment value.
What?
I'm submitting these for entertainment.
Negative
value.
1.7. Great.
Bring over.
And so that matches what they said the answer was. All right, so we got that part right.
Why do you mean
Okay, now we can do the part B. And part B is what is the distance traveled by that particle on that interval? So that's going to be the integral from 0 to 3. And we're going to take the square root of the velocity, the x component of the velocity, which is going to be t plus 1 to the negative 1 squared, and then the y component of the velocity, which is going to be t plus 2 to the negative 2 squared dt.
Wait. Negative 2 to 2. Yeah, that just became.
Okay, and I am pretty sure that we can't do that by hand.
No.
I'm pretty sure that that's not going to work out to something nicely, and I suspect that's the case, especially because their final answer is a decimal point. So that will be a plug and chug into the calculator.
Decimals in your head.
So is it a shock, or can you just put that in the calculator?
Yeah, we would just go ahead and in the calculator put that expression, and we should get that value back out. Is that a calculator section? Okay, I'll tell you what. Are we done with this problem?
Yes.
Yes.
All right.
Yeah. You're not gonna plug it in for the video, or?
No, you want to put in? We'll put it in the video.
Yeah.
We'll put it in the video. Here we go. Get our Inspire fired up. Now we'll have to see if we can remember that particular expression.
Or we could just get
You have it written down? Great.
Shift plus.
Shift plus sounds like a winner. So let me go to 200%. Add a calculator. Shift plus to get that. 0
Tab. You can press tab.
to 3. The square root of
T
t
plus 4
plus 1
to the negative 1.
to the negative first.
Square all that.
And then we need, so I need to have another set of parentheses. So we can square that
So I can parentheses in.
plus paren
T plus 2
t plus 2
to the negative.
to the negative second.
Yeah. And then square it.
And that's all dt. Survey says. And that looks like the same answer they had. Excellent. So I think we did it.
Go then.